And I guess we are live. Wow, it's been like a week or even more without any live streams. But anyways, we're doing Monday Night CAD today, and yeah, sorry for the interruption. And yeah, if you watched my latest video, it was about like my workbench, my lure making workbench behind me. And one of the things with the workbench is the paint holder, and it works great. Works really great actually, but sometimes, especially when I get new paint bottles that are not exactly the same diameters and tolerances of the other paint bottles, it might be just a bit loose and keeps falling. So we are going to fix this, and I kind of have an idea about how I'm gonna fix it, but it's just an idea, so let's see if it's gonna work out. So what I have at the moment, I think I have a bottle diameter, bottle height, okay. And what I do have is tolerance, number of bottles. So okay, so I have like X and Y number of bottles, and then this is generated by how many number of bottles I have. Like for example, if I want it to be 3, it could be like that. So this is fine. Odd Lures, hey, how are you? It's been a while since my latest live stream, huh? But hopefully everything is resolved now, so no more missed streams. So again, I'm gonna start from the beginning. What I'm trying to do today is, if you watched my latest video, I have this paint bottle holder. I want to improve it a bit, because sometimes if the tolerance of the paint bottle is not that great, or if I get a new paint bottle of the same diameter, but for some reason they have different tolerances, it could easily fall. So we need to fix that. You're great, glad to hear. Your latest batch of lures was amazing. Yeah, so the way I think I'm gonna fix it is I'm gonna have something here that it's hard to explain, but something like protruding out here. And when you put a bottle in, it compresses it and hold it in place. It's hard to explain. We'll see it, but we need to make the hole bigger than the actual diameter. So what I have here is I insert the actual diameter of the bottle. I measure it using my calipers, and then I have some tolerance, and then this will spit out the actual diameter that we need, which is bottle diameter plus some tolerance. That's it. Outer diameter, what is this? I think this is this right here. We're gonna have to play around with these. Thank you, that was some nice patterns I tried. Yeah, definitely nice. I need to work on my painting skills. I haven't practiced enough. But I think what we're gonna do now is, so we need a new row here above this one. Something called max bottle diameter. So we're gonna support a range instead of just a single diameter. So let's say we want to fit paint bottles from 30 to 35, for example, or 35 to 40, something like this. And yeah, we're gonna have to do a bunch of modifications to this. So let's start here by calling this the minimum. I think we're gonna have to do the same here. Hopefully this will not break anything. I think FreeCAD automatically updates. Let's see. Yeah, it automatically updates all of these. Interesting what it did here, but I think that's fine. So this is gonna be the minimum, and then we're gonna have some sort of a maximum. Let's put it as 40 mil for now. So we're not gonna use the minimum to do the cut, we're gonna use the maximum. And yeah, that's gonna require a bunch of modifications actually. So this one is diameter plus, okay, cool. So we need to get from here the paint bottle, paint, no, it's called bottle params dot max diameter. Okay, so we have some issues already. I'm guessing that's the total width. Okay, yeah, no. This is already using diameter, total width. Okay, this is using diameter. First center, okay, these are all the derived parameters. Something is wrong though. If we measure from here to here, that's for 12, which is correct, I assume. Number of bottles, thickness. Okay, maybe we don't have an issue. Just give me a second. If we... That's 2 mil. What's our thickness? Oh, it is 2 mil. My bad. We don't have an issue. I thought that we do. What is the distance between this circle and this circle? Also 2. Nice. Nice, we don't have any issues. So we need to clear this. Okay, so now, first of all, I'm gonna increase the thickness because I need it. Let's do 6, for example. Did it change? No. We have to hit enter for it to change. Okay, so we're gonna do some cuts here, and then do the thing that will hold the paint bottle in place. I'm a bit concerned that the thickness might be too little. We'll see, we can keep increasing it if needed. But paint all the params, we need some stuff now. We need to define the, what is it name? What is its name? The thing that's gonna hold the bottle in place. Compression something. Let's call it compressor. I know it makes no sense, but compressor thickness is, or width, let's go with width first. It's gonna be, let's say, 4 mil wide, and the thickness of it is gonna be 2 mil. Okay. So we have a width and a thickness, and we also need, wait, compressor. Let's call this a groove depth. And let's do this at 4 mil for now. So the idea is we need to cut here a groove. And I'm thinking about how to cut it because I can't just throw a sketch here and cut it down. We need this stop face. It's gonna be tricky. We have the thickness though, so we can go down by thickness maybe, and then do the cut. But here, before we do any of that, we might need to go back. Interesting. Okay, so that's our pocket. Then we did the lattice pattern, then we did another pattern. Now the easiest thing to do is to just do it now and do the patterns again. But I need to, okay, so that's the original one. If I want to reuse the same rays, I want to work with this pocket right here. I'm gonna delete the chamfer because this chamfer is not parametric, and I don't like things that are not parametric, so I'm just gonna delete it, and maybe we can add it in a parametric way. And here we have an issue with the holes. Huh, that's interesting. We'll fix this issue later. For now, let's focus on this thing. What datum planes do we have? We have a datum plane up here, which is base thickness. No, we don't need that. We can just create a new one, I guess. So let's attach a new datum plane to the XZ plane. I hope the audio is fine. And the focus, because I'm using autofocus today, usually I don't. Okay, so in the Z direction, we need to go by paint bottle derived params dot total height. Okay, that's very interesting. It's not height. I usually do that. It's not height. What is it? We have base thickness. Oh, wait. I think I used the bottle height. Depth and holder, maybe that's it. Depth and holder is bottle height multiplied by 0.4. So what is the total? It's the base thickness plus depth and holder. So if I copy this, go to derived parameters and let's put it here. Let's say this is equal to this value, and let's call it the total. Let's just call it depth. I don't know why I called this one height. For some reason it should be length. So we have total depth. Now we can go back to our datum plane, which I think I cancelled. So let's attach it here in the Z direction. We need to go by total depth. And we should be right here. Okay, cool. So now we can go against it by the compressor thickness. Nice. Do I have the first center? Okay, I have the first center X and the first center Y. We can do that right here. I can come to this datum plane and say in the X direction, I want you to go by derived params dot first center X, and in the Y, I'm guessing is it a positive or a negative number? Let's see. First center Y. I think it's gonna be, no, both are negative. Okay. So X and Y should be negative. Which makes sense, to be honest. Cool, that's it. That's it. We can come here and show the first pocket. Yeah. That's the one we need. And now here's the tricky part. So I want to create a groove here. That is exactly... Actually, it's not that tricky. Wait. We have it. Oh my god. Come on, FreeCAD. We have the width and the depth. So the depth can be... Yeah, we can use circles to do it. Let's see. So we want... Let's hide the datum plane first. Cool. So I'm gonna start by drawing two circles. One exactly the same as the previous, like as the hole itself, and then a bigger one. So this one is going to be the derived params dot diameter. By the way, why is it 80? Why did I multiply this by 2? Interesting. Yeah, it looked weird. I don't know why I multiplied it by 2. Okay, and this one is going to be the paint holder params dot diameter, but we're gonna add to it the paint holder params dot compressor depth. But since this is a diameter, we're gonna multiply by 2. Cool. So now we have exactly 4 mil from here to here. And for now... Oh no, we don't have to make them construction geometry yet. Let's just see. I mean, we can. There are many ways to do it. But we need 2 lines, 2 horizontal lines. And I want these to be symmetric. So I'm going to take these 2 points and this line, make them symmetric. And the distance between these two is going to be the width. So not the derived params, no. Why do I have so many spreadsheets? The compressor width. That might be too small, but anyways, we can change it whenever we want. So compressor width, and we have the depth correct. Now we can either trim these, but if we trim them, will it work? Will it still be... Let's see. If I trim this edge and this edge, yeah, no. What is under constraint though? Interesting. These two should be the same. Huh. Okay. Okay, which one of you is the issue? Is it because of the symmetry though? If we coincide, or is it because of the horizontal constraint? No. Okay, so we have symmetry, we have vertical distance, and we have 2 constraints. What are these constraints? Yeah, these are unrelated. It's the symmetry then. Interesting. Okay, that is fascinating. I mean, I can just constrain this to paint holder params dot compressor width divided by 2, and then it's gonna be symmetric. But anyways, okay, so that's our groove, and we're gonna pocket it downwards. How much do we want to pocket? It's a good question. This is our depth in holder. So depth in holder is from this circle to this circle. We need to remove 2 thicknesses from it. So let's see. Paint holder param, the depth or no. Bottle params, depth in holder minus paint holder params, the compressor thickness multiplied by 2. Cool. This is our groove. And now the tricky part. Daniel K just made my first 3D printed lure, which was a whopper plopper. I caught a ton of fish. Nice. Nice. It's amazing when you make your own lure and you catch lots of fish. Usually I don't catch anything on my lures, or I catch like 1 or 2 fish, and usually perches if I'm making like an ultralight lure, or that barbel that I caught. That was an amazing catch. It was like a trophy fish on one of my lures. But other than that one, I made the trout lure. We did live on Friday Night Lab, and I printed one, took it trout fishing with my friend. We went on a trout fishing trip, and dude, it caught so many fish. I was so happy with it. It's amazing. Okay, so now we want to somehow, on a curved surface, which is a circle, extrude something that goes like that. I'm thinking we can do a sweep, but I'm not sure yet if a sweep works. I'm in the USA. I got lots of bass. Oh, I wish we have bass here. That would be amazing, but we don't. We have zander and asp. I think asp is the closest to bass in terms of like the lures it can eat, but we don't have many of them. They're super picky. I'm still thinking about how we're gonna do this. I think it's gonna be a sweep. Probably a sweep. If we have a curve coming down from here, then it somewhat goes up. Let's try it. I don't want to waste too much time thinking about it. So we have the center. So basically what we can do is, I want to create a plane here, but first let me display the origin. So I need to attach it to the XY. Is it the XY? Okay, it's a bit trippy. This is the bottom, this is the front, left. Why did I do it this way? I don't know. And we need to move it in Z direction. Yes, negative Z direction by minus paint holder derived params dot first center Y. Yes. Nice. Right in the center. Maybe we can also do the X. Which direction is this now? Okay, this is Y, so not this one. this one, but the positive is in which direction? Yeah. Paint holder derived params. First center X. Let's go minus. I think it is minus. Okay. That's it. No, that's not it. Ah, okay, we are at the center. Yeah, still, it's fine. It's better than nothing. So what I wanna do is create a curve here somehow. Let's see, create a B-spline. Oh, we need a B-spline by control points. No, just the B-spline. So when creating a B-spline, you can do this, but it's not gonna work exactly as you want. You want at least when you're entering out of here, you want one that is vertical and then do whatever you want. And then here you want also one that is vertical. Why? Because now we can, it basically creates a smoother transition into the thing. So the more the bigger distance between this one and this one, the more perpendicular it goes to the inside. So we will make these vertical, and we'll also make these vertical. Now what I'm gonna do to make sure this is symmetric, there are two ways. We can either draw a line here in the center and give it a symmetry constraint, or I can take these 2 points, make them vertical, so they're always on the same vertical axis, but these two are not equal, so we need to draw a line from here to here and a line from here to here. These two lines have to be constrained geometry, not constraint, construction geometry, so they don't actually affect anything, and we'll just make them equal. Okay, now we need to place these in the correct position. So first one on the vertical distance from the center is going to be paint holder params dot base thickness plus paint holder params dot compressor thickness, and we need to put this in place. So that's gonna be the total. Oh, not here. We need to go to the formula editor. The total depth minus compressor thickness. Cool. Nice. I'm still not sure what to do with this. Maybe we can make these two vertical also. Where is it? And I'm thinking of also making them symmetric. Yeah. Probably gonna do that. Let's just give this a number for now, like 5. But we need to make it proportional somehow to yeah, to the height, because the height can change. So these two, how are we gonna make them in a way that is also proportional? First of all, let's make them symmetric. So I'm gonna do the same trick, even though there are other ways. Probably I should have done the other thing, but let's put this one here. Actually, yeah, it's definitely a better idea. So we're gonna get a line here, and we know this to be exactly in the center. We need to go by paint holder params dot base thickness, and then we can get the paint holder derived params. No, bottle params dot. Interesting. Not height, depth and holder divided by 2. Now we're in the middle. So we can take these two in this line, make them symmetric, and no need for these now. We're gonna delete these lines because we can do the same trick here. Make them symmetric. Nice. So we have a couple of stuff missing. This line doesn't actually need any special thing. I'm just gonna set it at 8 for no reason. Make it construction geometry. Okay, so we're gonna look for a shape that we like and then somehow someone constrained it to be proportional. But first, I forgot to put this in place. So we're gonna do a horizontal constraint now. We know the distance from here to the edge here, and that is diameter. But we need to add to that. Actually, I think we can start from diameter. I still don't know how the sweep thing works, so let's assume that we're gonna start from diameter for now, and then we'll see. And we need the radius, not the diameter, so divided by 2. And then we'll get back to this and change it if we can't do that. Okay. Now these two, and this is not final. It shouldn't be 5. What is our? This is 30. We can do something like if we want it to be 5, which looks good. We can get our paint or not paint. Bottle params dot depth and holder, which is 30, and divided by. Interesting. 10 will give us 3. No. Oh my god. It's thick 6, I think. Oh my god, that's basic math. Yeah, it's 6. That was funny. Okay, and I kinda like this, but first we need the actual distance. It's gonna be tricky because the actual distance is not the distance to this point, it's the distance to this point right here. So we actually needed a point on this, and an extra point. What if we can move this? Can we do this trick? Interesting. We can. Okay, so let's move this point now to where we want it to be, which is the minimum diameter, right? So instead of this being just 8, we can go to bottle params. No, it wasn't in bottle params. Where did I put it? Yeah, it was min bottle diameter. Huh. I'm confused. Okay, It's here. Divided by 2. We should probably have some tolerance, but for now, let's assume that we don't. This actually looks good. And for this, we can also do, or we can divide it by 5. So paint holder params dot, no, it's bottle params again. Depth in holder divided by 5. Nice. So now we have a path to sweep on, but we need the thing, like the actual sketch that we need to sweep. So we need to go back to this datum plane. No, not this one. This datum plane. And create a sketch here again. Yeah, we basically need to repeat what we did. So this one, diameter is diameter. And this one is diameter, but we want to add the thickness of what was it called? Compressor. Multiplied by 2. Okay. So this should be like 2 mil. And again, exactly what we did on the other one. The distance between these two is going to be the compressor width. And okay, the distance between this and this is going to be half the compressor width. Okay, cool. And now we can trim. No? Yeah. Okay, this is the profile we want to sweep. Let's see how it's gonna work. I haven't done a sweep in FreeCAD before. Do they call it pipe? They call it pipe. Sweep is selected sketch along a path. Let's see. Ah, okay, that's not bad. Yeah, it's too thick though. Remove edge. Do I just click OK? And here it is. It looks bad. Oh, we didn't take into consideration tolerance. We can go back and modify it in a bit, that's fine. But is it actually, where is the measure tool? It is 2 mil. Nice. Clear all. So let's go back here and change this to 1. See how it looks like. Okay, this is much better. Now, will it work? I don't know yet. But what I do know is that I need to modify the sketch. we need to add some tolerance. So we need to add the tolerance here. Compressor width plus paint holder params, the tolerance multiplied by 2, and let's copy that. And we need to put it here. Okay, actually, yeah, that's it. 4.4, 2.2. Close. And now if we view this, we have tolerance. Now again, I'm not sure if this will work or not. I'm trying to think about it, because if this wants to go in, it might work. I don't know. We have to try it. And we can play around now with the min and max bottle diameters. Let's set the min to 30. Okay. That's a bit weird. So I think, like, if we do a 34 mil bottle, it will work fine. But if we put a 40 in here, I don't think this will just like go in and then come out later just fine. But anyways, I need to actually test this. Assuming this is what we want, let's crap. I did not think this through. I need to actually revolve it, not revolve it, to do a polar pattern, and then do lattice, then do like a regular pattern this way and regular pattern this way. I did not think about the polar pattern. Let's see if this works. So I need to go to lattice workbench. I need to create a polar array. Placement. Is there a direction here somewhere? No. No. So we have to change the angle. So if I rotate it now, yeah. No, it's not what we want. Is it Y? Okay. So I need to do this, I guess. Probably not. How do you do that? I remember I did it once. Now the easiest way to do it, I think, is just to transform it. And okay, this is trippy. Wait, what? What's going on? Okay. Is this it? Yeah. Nice. Thank you. So what was it? It was 1 on the X and 90 degree on the angle. Didn't I try that? Maybe I didn't. Position. Now we need to go in the Z direction by derived parameters, the total depth, which did nothing apparently. Ah, it's not the Z. Yeah, that's very trippy. Is it the Y? No, it's X. What? Ah, it's Y. It's negative Y. Why is it negative Y? What if we do minus 90? No, it's the same. So it has to be minus paint holder params dot nah, it's paint holder derived params dot total depth. Okay. This is very weird. Actually, let me try something. If I just take this pockets, okay, so we need the pocket and the pipe. If I take these two and the polar array and did this, what's gonna happen? No, it's not what we want. I never tried the polar array in part design. How will this work out? Let's put it in place first. So X is this way. So that's gonna be minus paint holder derived params dot first X. And that Z is basically Y. So it's minus that first center Y. Hi there, what are you making? Monolocos? Okay, I'm not gonna try to pronounce your name, sorry. We are making, I don't know if you watched my latest video or you're new here, but basically I have a paint stand that, yeah, it's right here behind me. Probably out of focus, but it's a paint stand and I have a parametric paint bottle holder where we can like change the diameter of the bottle and like how many number of bottles on each axis, like on the X and Y axis we want, and it will create this thing for us to 3D print. And now I'm trying to add these so that when you put a paint bottle, they compress and hold it in place, because at the moment they're just like loose and they could fall. Yeah, so you want to do a polar array and the number of elements are 4, but that's not where we put them, right? No, it's count 4. Okay, cool. Where is the radius or the diameter? Not in the position for sure. That's cool, thank you. Okay, here's the radius, nice. So that's the paint derived params the diameter. No, because that's a radius. So divided by 2. What else do we need? I mean, this should work. Let's see. Okay, it does work. Nice. Do we need 4 though? I think we do. Okay, now we need to take this pattern and wait, I forgot. Yeah, this one and these two. Okay, cool. So we can take this pattern and this array, but first let me save. so it doesn't crash. And let's do a pattern. Cool. Now we take this pattern and this array and pattern again. Nice. Very nice. Okay, and now if we come here and change this to 3, it's gonna take a while. Now we have too many patterns. But it works. I love parametric design. It always amazes me. Now these are a bit of an issue, but that's fine. They're just screws. Okay, cool. Cool. Back to 2. 5 by 2 is enough. Okay, what else? I think that's it. That's what I needed to do. Now these chamfers that we want to do here, it's very hard to make it parametric, to be honest, because where is it? Part design. I can chamfer it here, give it like a 1.6 chamfer, but the problem is, let's go back, for example, let's save. And let's change this to 6, for example, like 6 bottles on the x-axis. It's gonna break for sure. 100%. It didn't, wow. Okay, that was pure luck. But I remember we chamfered the one on the top and now it's the one on the bottom. Yeah, it's not stable. Yeah, I think we chamfered the top one and now it's here. Like if I return this to 5. It might change again. Yeah, now it's the one on the top. Yeah, this one is off the table. I can do a manual chamfer. Like I can go here and draw 2 sketches exactly on the position of this screw. But it might not be parametric, because what if this screw turned out to be somewhere here in the middle? How I'm gonna chamfer this, because I need to draw it down here. I could draw a chamfer and then extrude everything up, but yeah, I don't think that's a good idea. I think for now I'm not gonna chamfer. What I'm gonna do is, like, if I want to print it, after I modify all these parameters and I made sure everything is exactly how I want, then I do the chamfers and export the file. And then delete the chamfer because it might break things. But overall, I think that's it. So what I'm gonna do is I'm not gonna actually put the bottle diameter at the max. I'm gonna do it like, if I want to support, let's say 30 up to 35, then I'm gonna put it at 40 here, because I doubt that this will compress all the way in. So 40 is not realistic. It's just a number in a spreadsheet. So consider this as like not max bottle diameter, but it's the diameter of the hole. So yeah, I'm gonna print this and try it out. Of course, I'm not gonna print like 5 by 2. Probably do like 2 by 2 or 1 by 1. Does this even work? Yeah, it does. Screws are a bit weird, but that's fine. Yeah, I'll print that and try it. It should print well without any support. I don't think that's a steep angle. I think this should be fine. Should I make it thicker? It's 1. You can do 1.2, I guess. Yeah, the 2 mil was too thick, but I think 1.2 is fine. It'll be stronger. And I think PLA is not the best material for this, but I'm gonna test it with PLA just to see how things fit, and then maybe print it out of ABS or PETG. I don't think PETG is also a good idea. Maybe ABS. Yeah, I think that's all for today. Thank you all for joining. And if you don't know what I'm talking about, you can actually check my latest YouTube video, which is about my lure making setup. And you can see the paint holder. So this is what we're modifying at the moment. So yeah, if you look at like the Vallejo paints, they fit really well. But the what was it called? These paints, the speed paints, they don't actually fit well. They're a bit loose, and these are actually a bit more loose than these. So these are barely hanging there. They just need like a little blow and they're gonna fall. So hopefully this will solve the issue. Hopefully. Lewis, thank you. Hope that it works. Looking forward seeing the results. Yeah, I will definitely post the results on Discord once I print it. I'm not sure I'm gonna print it today. It's 11 p.m. So probably in the next couple of days we'll post the results on Discord. Make sure you join Discord if you haven't, if you're interested, of course. And yeah, that's all for today. Thank you guys for watching till the end, and have a nice week. Not weekend, it's Monday. I keep forgetting what day it is. So yeah, have a nice week. Bye guys.